Okay, I want to introduce our next speaker, Professor Philip Stark. Philip is a professor of statistics at, I guess, recently retired? Last month retired, from the University of California at Berkeley. But for the last nearly 20 years, he has been studying a fundamental issue in elections, which is post-election auditing. And he is the inventor of and popularizer of and chief practitioner of risk-limiting audits, the sort of, if you will, gold standard of election auditing. And he's been developing this theory and teaching it and so on for decades now. And so we're proud to have Professor Philip Stark.
Start with a one-item IQ test for me, which is, can I get my device hooked up to the... Is this... All right, it's recognizing something happened. Choose the mirror. Choose content, window and app, choose mirror this window. Good. Ooh, how about that? Thank you all for coming. I'm going to talk a little bit about evidence-based elections and risk-limiting audits, and risk-limiting audits feed into evidence-based elections. Actually, am I audible? I should probably stand in front of the mic. Okay, is that better? Yeah, all right. So the work I'm going to talk about, there's a lot of, I've had a lot of collaborators over the years. Several of them are in the room. Karsten, Josh and I have written papers together. Anyway, so this is not a solo effort, although I'm going to cite myself way too much. The idea of evidence-based elections goes back to 2012. David Wagner, a computer scientist, and I published this paper in an IEEE journal. And the idea was that the way that we run elections in the US right now, I would call procedural rather than evidence-based. So we have some rules, you use certified equipment, you follow the rules, and then you say, we're done, right? That must be the answer because we followed the rules. And the analogy I like to use is that's kind of like a brain surgeon saying, I used a sterile scalpel, I followed surgical procedure, therefore the patient is fine. And it's like, you might want to look at the patient and you might want to look at the election. You might want some other evidence about how well things went. And in particular, what would you really like? You would like strong, convincing public affirmative evidence that the reported winners really won. That it would be nice to know that the vote totals are exact. It would be nice to know more things. It would be nice to have forensic audits. It would be nice to have root cause analyses of failures. But the leading bit in all of this is, did the reported winners really win? And so the focus of this is how can you conduct elections in such a way as to make that happen, make that true? And the answer is you can. And the secret, more than anything else, is really shoe leather. It's really physical security. If you have physical security, if you generate the paper trail in a trustworthy way, and then you inspect it in a strategic way, you can get strong evidence that the reported winners really won, or correct the answer if the answer is wrong. But you have to be careful about what you use technology for and how. But there's no magic here. In some sense, this is a solved problem. Right, so as we all know, every computer is subject to all kinds of problems. We shouldn't just blindly trust results. But one consequence of this is that when we're using computers in elections, we should really limit them to roles where a failure doesn't keep people from being able to cast a vote on election day, and where failures that could cause the wrong candidate to appear to win can be detected and ideally corrected before the outcome is final. So you want to be able to make an end run around the technology to ensure that the reported winners really did win. Software independence, this beautiful idea introduced by Rivest and Wack, is the idea that errors could in principle be detected. And that's crucial, right? You need to have a voting system that makes that possible. But can be detected doesn't mean will be detected. You actually have to look, right? And that's what auditing is about. It's about looking. Even better, you would like to be able to correct wrong outcomes before they become certified, and that's tied into strong software independence, but it's, again, that's not quite enough. I didn't mention, as I read this, I remember, and Rich is in the room, and Rich and I have co-authored papers on this, the same stuff too. All right, so the origin of these ideas is from 2007 California Post-Election Audit Standards Working Group, which David Jefferson chaired. He invited me to participate, which changed my life. When we were, so we heard former Secretary of State Shelley speaking earlier today about kind of the preamble, noticing that there was a really serious issue with the computers, with the software, with the vendors, et cetera. And then he mentioned his successor, Deborah Bowen, who spoke here last year. She put together this top-to-bottom review in California, which involved people poking at the equipment and software, both with and without access to source code and other documentation. In addition, she put together an audit standards working group with the idea being the technology is going to be vulnerable. Can we use audits to somehow protect against those vulnerabilities? So we looked at what was going on in other states and in California at the time. We took public testimony. And at the time, some states audited. California had an audit. Some states didn't audit. There wasn't a whole lot of motivating principle behind the audits that were being done. They were of the form, run some ballots through the machine, either a batch that has already been tabulated or use something that's already been tabulated during the election, or construct your own batch after the election and run it through the equipment. Recount that batch by hand and see whether the two agree. If they don't, note that they don't. Maybe try to explain why they don't. And that's kind of the end of the story, right? There was no requirement to do additional investigation. There was no requirement to figure out whether that changed the outcome. There was no motivation for how much to audit or how to audit, other than maybe at random in some states and other states not even that. And the justification for this was generally people saying, this audit is just checking, do the machines work correctly? The problem with, there's a lot of problems with this, but one of them is correctly is not really the right answer. It's not really the right question to ask, right? What does correctly mean? It's not like it works perfectly or doesn't work at all. It's going to work with some error rate, and the question is that error rate big enough to change the outcome, or can you show that it wasn't, right? So correctly isn't the right thing. Computer scientists were getting involved in the question about the same time. This is roughly the mid-2000s. And they formulated a much better question. They formulated auditing as a detection issue. So if the machines malfunctioned to the point that they produced the wrong winner, what's the smallest sample of precincts or ballots or something else you need to look at, selected at random, to have a large probability of finding at least one mistabulated vote, right? Much more sensible question. There's a principle behind that. You're actually thinking about the election results. Great idea. The problem is that in pretty much any real election with hand-marked paper ballots, if you look at a reasonable number of ballots, you will find at least one that was mistabulated, because people don't mark ballots the way they're supposed to, right? They mark it in pencil instead of pen. They circle the oval instead of bubbling it in. They're going to do something, all right? So merely finding a single miscounted vote is not evidence that the outcome is wrong. This is a better idea, but it still somehow doesn't answer the right question. And the big change of paradigm happened in 2007, which was moving towards this idea of affirmative evidence. It's not the absence of a smoking gun. You want evidence there was no murder, right? It's a different thing, right? They're the patient, the person's alive, right? The murder didn't happen. So the idea there is that an audit should provide strong evidence if the outcome is right. It should correct the outcome if the outcome is wrong. What would you really like to know when you're done with an audit? You'd like to have confidence that the outcome is right. Well, what if the outcome's wrong? You shouldn't have confidence that the outcome is right. So the audit has to have the ability to correct the outcome if the outcome is wrong, or you do not end up with confidence that the outcome is right. You need to be able to detect it and correct it. And the important thing, and this is actually tied into the detection paradigm as well, is that what you're checking is the outcome of the election. You are not checking the equipment. You are not checking the exact vote count. You're checking something that if the margin is wide, you have a much bigger tolerance for error than if the margin is narrow. You're just checking whether the reported winners really did win. What I mean by the outcome is the political outcome. All right, so what is a risk-limiting audit? It is an attempt to protect against certifying incorrect electoral outcomes, against declaring the wrong people to be the winners. Any audit that has a maximum chance, a known maximum chance of not correcting the outcome if the outcome is wrong, is risk-limiting. Right? This is a property that audits have. It is not a unique way of auditing. It's a characteristic. But what is the risk? The risk is the largest chance that the audit won't correct the outcome if the outcome is wrong, where maximum means over all ways that the audit could be wrong. It could be that errors were made in the tabulation in one precinct, or errors were made in different ways, or somebody forgot to scan a box of ballots, or 6 boxes of ballots, or the candidates were flopped in the ballot definition file, or. There's a zillion ways that things could go wrong, and the risk-limiting audit is guaranteed to have a large probability of noticing and correcting the outcome, regardless of why the outcome is wrong, right? Now, you obviously can't do that no matter what. You need something, you need a touchstone. You need a trustworthy paper trail in order to be able to do that, and I'll talk about that more. Okay, so RLAs are not a single method. They're a property that some methods have. Not every audit that uses statistics is a risk-limiting audit. And we're finding a lot of abuses in government, among legislators and election officials, just sort of like, oh, we took a random sample, so we have a risk-limiting audit. Well, probably not, maybe, I don't know. Okay. You can't limit the risk if you can't correct a wrong outcome. So if you're doing your audit after you've certified the outcome of the election, you are not doing a risk-limiting audit. You might still be doing something valuable, but you can't limit the risk of certifying a wrong outcome if you don't do it until you've already certified the outcome. And another abuse that we're seeing is some of the states that are doing what they are calling a risk-limiting audit are auditing 1 or 2 contests and then saying, voila, no votes were flipped in any of the blah, 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 everything is fine, nothing to see here, we can all go home, right? And that's just not true. If you didn't look, you're not going to see. You can't borrow strength from contests you didn't audit. And finally, and kind of the most serious problem of all, is that if you apply risk-limiting audit procedures to an untrustworthy paper trail, you do not limit the risk of anything. You just distract people from the more fundamental problem that there's not a trustworthy paper trail, right? Okay. An RLA is a way to tie a bow around a well-run election to demonstrate that whatever might have gone wrong didn't change the outcome. It is not a way to somehow resuscitate a poorly run election and sprinkle magic RLA dust on it and somehow get a trustworthy election out of it. And we're seeing that kind of claim happening well. All right, so can't limit risk without a trustworthy paper trail. What do we mean by trustworthy? It means that if you did a complete accurate tabulation of that paper trail, it would show who really won. Well, now this is circular. What do you mean by really? Well, that gets even more complicated, but kind of the expressed preferences of the eligible voters who cast ballots, right? So if this is at least getting to the point of someone casting a ballot, it's not worried about disenfranchisement and other things. Some records are born untrustworthy. They are recorded on a malleable medium, like digitally instead of on paper, or they put vulnerable technology between the voter and the vote record, like ballot marking devices do, or most internet voting systems are putting, there's something in the middle that could alter what the record ends up containing. So some are born untrustworthy, but even if they start as hand-marked paper ballots, which are the most trustworthy technology right now for recording votes, you have to make sure that you keep them trustworthy. How do you keep them trustworthy? You need physical inventories. There are a lot of jurisdictions where they have absolutely no idea how many ballots were cast except what the voting system tells them. That's not enough, right? So you need demonstrably secure chain of custody, appropriate physical security. You need to know that only eligible voters voted, or that the number of ineligible ones is so small that it couldn't affect the outcome of anything. You need rigorous ballot accounting. You need a lot of the things that are part of a canvass in states that have a good canvass, but that are not part of the canvass in some other states. Or perhaps on the books as part of the canvass, but aren't routinely carried out. And Georgia is in that category. A key thing that you need in order to maintain a trustworthy paper trail and to conduct risk-limiting audits is you need a trustworthy upper bound on how many ballot cards could contain any contest in the election, or any contest that you're auditing. The reason being, if there could be 1 trillion ballots that have a vote for Bob, Bob might have won, even if the votes that you can keep track of all, show Alice as the winner, right? So you need some bound on that. The first paper on risk limiting audits didn't call them that. It was this 2008 paper in Annals of Statistics. This was organized around batch-based auditing. It was tried to be modeled on the way that most states were conducting their statutory audits. Like, how can we tweak this to give us more information, more trust, more reliability? We did pilots in 2008, and the first paper reporting pilots came out in 2009 in EVT-WOTE, which is a conference that has died. Although people are trying to resuscitate that, is that? Yeah. The Rice Group, yeah? Dan Wallach et al.? Okay, the idea caught on. The National Academies of Science, Engineering, and Medicine, and their Securing the Vote, Protecting American Democracy 2018 endorsed them. They've been endorsed by the Senate Select Committee on Intelligence, Presidential Commission on Election Administration, a bunch of other entities. There have been a bunch of pilots in a bunch of states in Denmark, which Karsten did. There are laws in roughly 15 states, maybe more since I last checked. Not all the laws are very good. They use the words risk limiting audit, but they don't always give you a risk limiting audit. There are now risk limiting audit methods for a broad variety of social choice functions, including plurality, multi-winner plurality, supermajority, various proportional representation, things like parliamentary election kinds of stuff, instant runoff voting, board account, star voting, and pretty much anything that's a scoring rule where you sort of add up points for people and whoever gets the most points wins. These are just, I'm just going to flash some of the state of the art in front of you. In 2020, there was kind of a unifying way of looking at things in terms that reduced auditing of all of those different social choice functions into multiple instances of the same statistical problem. That statistical problem is, here's a list of numbers between 0 and some known upper bound. Is the average of this list of numbers bigger than a half? All right? So that's just sort of the canonical core statistical problem now, and there's a lot of different ways you could draw samples to test that. There are a lot of different ways you could address it, but if you can solve that problem, you can do a risk limiting audit of a vast variety of social choice functions. And then methods for measuring risk, et cetera, have evolved over the years. Methods for trying to preserve the privacy of votes, both in the way that the audit is conducted and the way that intermediate results are reported, in making sure that you can't trace a voted ballot card back to the voter who cast it, and things like that. There's a lot of wrinkles around how do you do this in a way that stays clean, and how do you do it in a way that is a good match to the logistics of how an individual jurisdiction manages its paper and runs its election, and the capabilities of the voting technology, because there are methods that can be incredibly efficient for risk limiting audits. Efficient meaning when the audit comes along, you don't have to look at many pieces of paper selected at random. You have to look at some, but efficient methods require more data export from the voting system. They require more accounting. They require kind of more precision in the setup. And some of the less efficient methods require basically nothing, and I'll try to hint a little bit about how that works. Okay. These are some papers on auditing instant runoff voting. I'm just going to flash this up partly to give you an idea of the workloads that are involved and to try to convince you that it actually is feasible to do a risk limiting audit of every contest in every election. And this is sort of the moral equivalent of measure twice, cut once, right? It's sort of vote once, count a little more than once in order to get confidence. So this is a method that involves making sure that every contest in the election gets enough ballots looked at to have high confidence that the result is correct. It includes the possibility that the margin is so small that you may have to do a full hand count of that contest. But if you draw the sample appropriately, so Orange County, California is, I think, the 5th largest election jurisdiction in the country. It's larger than many states all by itself. Has over 1.8 million active voters. In 2020, they had 181 contests on the ballot. So not everybody gets all 181 contests, but because of the overlapping geography, there were 181 contests in all. You could have audited all of them to a risk limit of 5% by looking at 0.65%, so 2/3% of the ballots cast. That's not crazy, right? That's not unattainable. In 2022, it would have been a little bit more. They had 214 contests in all, and you would have needed to look at about 3% of the ballots of the cards cast, and that includes 3 contests that had margins below 0.1% and 9 with margins below 0.5%. So the smaller the margin, the less the tolerance for error is, because a smaller number of misinterpreted votes or ballots could have caused the wrong candidate to appear to win. So it's always going to be the case that for a given method, the workload's going to go up as the margin gets smaller. And the question is it still manageable? All right. So how do you do it? Like when it's time to do it, what do you need to do? All right. You need to establish that the paper trail is trustworthy. You need to go back and check the ballot accounting. You need to do a proper canvass. You need to check chain of custody. You need to do all these things, because if your paper trail isn't trustworthy, I'm not sure what you're doing. I'm pretty sure you're distracting from election integrity rather than helping it. You need to pick a risk limit, and then depending on the particular method you're using, you might or might not need to export some data from the voting system other than just who won. You'll need to know something about what social choice functions were used. Is it plurality contest, et cetera? For each of the contests that you're going to audit, you need to pick an initial sample size. So one of the things that makes a risk limiting audit different from previous ways of thinking about it is the initial sample size only matters for logistical reasons. It does not matter for integrity reasons, because the audit doesn't stop until it's seen enough to have convincing evidence that the outcome is right. The way that a risk-limiting audit corrects the outcome if it's wrong is by not stopping until it's become a full hand count. So you've seen everything, and now you know who really won, right? You've done a careful retabulation of the trustworthy audit trail. So you pick an initial sample size, and this is really just for logistical efficiency. You would probably, ideally, you want to be, one and done, right? You want to make sure that you pull an initial sample that's big enough to confirm the outcome if it doesn't find big problems. But that's less of an issue. You're going to have to manually read the votes off the ballots that were selected, and the ballots that were selected could be selected by pulling individual ballots at random from those that were cast, or pulling them in batches, like recounting precincts, the way most statutory audits work or whatnot. That turns out to be a very statistically inefficient way to do it. You have to touch a lot more pieces of paper if you're recounting batches than if you're looking at individual ballots. I could try to give some intuition for that, but I'm not sure I have time. All right, so now you've looked at your sample, and you got to check. Have I met the risk limit? Do I have sufficiently high confidence in the outcome of all the contests? If not, go look at more. If not, go look at more. If not, go look at more until eventually you have high confidence, or you've decided that it's taking so long you might as well just do a full hand count, or you have done a full hand count, and you know what the right answer is. Right. If you ever get to the point of doing a full hand count, whatever that shows replaces the reported result, whatever the reported result was, if they differ. All right, so I've kind of glossed over measuring the risk. Like, how do you tell if you've met your risk limit? How do you measure the risk? So there's a lot of different ways of doing this. They depend on how the sample's drawn, how much information you're taking out of the voting system, the social choice function that you're trying to audit. There's lots of different ways of doing this. The active research is trying to expand the list of social choice functions for which we have any method, and right now, the one that's the biggest sticking point is single transferable vote, which is sort of a multi-winner version of ranked choice voting. And right now, there is no efficient way to audit that. And the other directions are trying to come up with ways of measuring risk that result in smaller sample sizes, but are still rigorous. Okay. The simplest method that there is doesn't involve exporting anything from the voting system. It's ballot polling. And you can think of it as an exit poll, except instead of asking voters how they voted, the voters might or might not tell you, they might or might not answer honestly, you might not be able to, there's a lot of issues. Instead of asking voters, you're asking the ballots, how were you voted, right? And the ballot has to tell you, right? So this method results in modest sample sizes for modest margins. The sample size grows very rapidly as the margin shrinks. It tends to grow like 1 over the square of the margin. So if you cut the margin in half, you multiply the needed sample size by 4. And I mean, at least until you get to the point that you're looking at most of the ballots, then it's not quite that bad. It still is more efficient than the way a lot of statutory audits are run. It's still more efficient than recounting entire precincts worth of ballots. And it wins even in the early pilots that we were doing in California in the 2010s. It demonstrated it was pretty good. And one of its another of its nice features is you can actually do the arithmetic of doing the risk calculations by hand with a pencil and paper. And if you're interested in doing a simulation of this, in the break right after this talk, we're going to simulate a ballot polling risk limiting audit. We have a pile of paper over there of like marked ballots, a ballot manifest explaining how they're stored, and we'll go through, roll some dice, draw some ballots at random, and keep going until we've confirmed the outcome of this mock election for a mayor of voting village or something like that. So this has a lot of advantages in terms of simplicity, observability, et cetera. Yeah.
You mentioned rolling dice. So how do you pick which ballots to use? How do you prevent that from being manipulated?
So how do the ballots are going to be selected at random according to some random rule. The particular random rule is going to depend on the audit method. So things that are, for example, based on auditing entire precincts, you can do audits of that kind more efficiently if you have like a bigger probability of sampling bigger precincts and smaller probability of sampling smaller precincts. For auditing a particular contest, what you really want is each contest to get enough scrutiny. So you may target the sample towards the contest that you're auditing. But in terms of the actual mechanical implementation of this, the way that it's being done in practice in Colorado and other states that are doing this is typically rolling 20 10-sided dice to generate a bunch of entropy and putting that into a cryptographic quality pseudorandom number generator to generate the list of ballots to go get. It's not cryptographically secure in that there's no issue to sort of reseed it and things like that. It's not the issue is, can you discover the seed? It's simply, is it something that somebody could predict what the sample would be? So it needs to be strong enough in that regard. So that's typically how it's done. The PRNG is disclosed source. Right now, the methods that most people are using are based on SHA-256 and counter mode or something like that. So, yeah. Okay, so let's try to walk through how to check whether, yep. Oh, I lost it. I'm back up here. What do I need to do here? Back, okay. So we have Alice and Bob, and there's a claim that Alice won, that Alice got more votes than Bob, all right? What we'd like to do is develop a way of checking that claim so that if Alice didn't really get more votes than Bob, there's at most a 5% chance we're gonna bless the outcome. We're gonna stop without doing a full hand count to figure out who really won. So that's the goal, and I'm gonna walk you through a way of doing that. Okay, so we have some pile of cast cards, and I'm going to pretend that that's a trustworthy pile, that it was constructed from hand-marked paper ballots primarily, that it's been curated well, that we really can trust that every vote, every ballot there was validly cast, and no ballots fell on a truck or fell off a truck or whatever. So any particular card is going to have a vote for Alice, a vote for Bob, or a vote for neither. So it might have a vote for neither if that card doesn't contain the contest, or if it's overvoted, or if it has a vote for Carol in the same contest, or something like that. Right now, we're just trying to see whether Alice got more votes than Bob. So if Alice didn't win, either Alice and Bob are tied, or Bob won. Okay? If Alice and Bob are tied, there's the same number of votes for each of them. And if Bob won, there's more for Bob. Right? So let's imagine selecting a ballot at random from this pile of ballots. If Alice didn't win, what's the chance, if we're sampling uniformly at random, we'll reach in this pile and pull out a card, what's the chance that that card shows a vote for Alice? Well, if she didn't win, it's either the same as the chance that we get a vote for Bob, or less than the chance that we get a vote for Bob, right? Because there's either the same or more votes for Bob than there are for Alice. This I hope is pretty intuitively clear. If Alice really won, there's a bigger chance that we pull a vote for Alice than that we pull a vote for Bob. So what we're going to do is set up a gambling game, right? We're going to bet on what a ballot card picked at random is going to show. And if it shows a vote for Alice, we get back what we bet. We win. If it shows a vote for Bob, we lose our bet. And if the card shows anything else, no money changes hands. Okay, so if it doesn't have the contest or a non-vote, overvote, something like that, you get your money back. Okay, so if Alice didn't win, this is an unfavorable betting game, right? At best, it's fair, and you expect to get your money back. But if Bob really won, if it's a tie, it's a fair game, you expect to get your money back. If Bob really won, this is an unfavorable game, you should expect to lose money in the long run, right? Bigger chance that you're going to lose your money than you're going to make your money. So far, so good? Right. This is the key. This is really the key to everything that's going on. Okay. All right, so here is, I'm going to set that we're in Vegas. We're going to gamble on ballots. This is ballot betting. This is risk limiting audits. Start with a bankroll of $1. You can bet any amount up to your current bankroll on what the next ballot drawn at random is going to say. You draw that card. If it has a vote for Alice, you win. You get what you staked back, right? If it has a vote for Bob, you lose it, and if it has anything else, no money changes hands, right? You break even. If you go broke at any point, it's game over, and you have to do a full hand count of the election. Okay? What's our stopping rule? How do we decide when we've won enough? So it should be clear that if this is a losing venture, if Bob really got more votes than Alice, this is a money pump where the money goes from you to the casino, right? You're unlikely to make much money in the long run. And it should be clear that if you make a whole bunch of money, that'll be evidence that there's more votes in there for Alice than for Bob, right? Okay, so what we'd like to do is some quantitative, precise thing that says if you win a bunch of money, it's really implausible that Bob won or that it's a tie. So it turns out that problem was solved in 1939 by a French mathematician named John Gideon. And what he basically said is if you have a game that is fair or unfavorable, a series of games like that, and you bet on them in that way, where if you ever go broke, you're out of the game, et cetera, the chance you ever multiply your initial stake by a factor of k is at most 1 divided by k. So the chance you ever double your initial stake is at most a half. The chance you ever multiply your initial stake by 10 is 1 over 10, 10%. The chance you ever multiply by 20 is 5%, 1 over 20. All right? So this is a long-standing math theorem that ties confidence in the election to this hypothetical betting game that we're thinking about doing. So if we play this game and by clever betting are able to get our initial stake of $1 up to $20, that's strong evidence that there really were more votes for Alice than for Bob, because if it had been a tie or there were more votes for Bob, there's at most a 5% chance you would ever get up that far, no matter how long you betted and no matter how cleverly you betted, no matter how smart you are at doing this. Okay, so, all right, it's straightforward to modify this idea for sampling ballots without replacement. All you do is sort of adjust after you see each ballot for what must be left if Alice really, if it was really a tie or Bob won. So here is the whole, kind of the whole thing turned into almost an algorithm. For every winner-loser pair, so suppose that we, instead of having just Alice and Bob, we had Alice and Bob and Candy, and Alice is the reported winner, then there's two things I need to show. I need to show that Alice got more votes than Bob and that Alice got more votes than Candy, right? So I can play two games in parallel based on the same ballots being drawn, and in one of them, I lose $1. I lose my bet if the card is for Bob. In the other game, I lose my bet if the card is for Candy. In one of them, in the first one, if the card is for Candy, no money changes hand. In the second one, if if the card is for Bob, no money changes hands, et cetera, right? It's kind of the same thing. And you play them in parallel using exactly the same sample. All right. So you keep playing these games until either you get to $20 in both of those games, or you've seen every ballot, or you get bored and decide to do a full hand count, or you go broke in one or more of the games. Okay? And if you've seen every ballot, you know the right answer. If you get bored and do a full hand count, you know the right answer. And if you go broke, you have to do a full hand count, and then you know the right answer. All right? That is a risk limiting audit with a risk limit of 5%. It's kind of that simple as a result of work done in the 1930s. Okay, there's similar ways of characterizing the winner of other social choice functions. They still come down to sort of betting on ballots in this way. They still boil down to this theorem proved by Veal. Okay, all right. So Veal proved that if Bob really won or it was a tie, you are unlikely to ever make much money. But if Alice really won, you can make money, and now audit efficiency is tied to how cleverly are you betting so you can make the money as quickly as possible by drawing as few ballots as possible, right? So now we get cleverness, right? So we get a risk limiting audit regardless, but if we can pick our bets well, we can reduce the sample size we need before we stop. So how do you do that? So the fastest you could get to $20 is in 5 draws, basically doubling your money. You start with $1. After, if you win, you now have $2. If you win, you now have $4, $8, 60, right? So you get to $32 after 5 draws if you really, if you won all of them. But that involves betting your entire stake every time, which means if you lose even once, you're out of the game and you have to do a full hand count, right? So you're not going to want to bet your whole stake. You're going to bet some fraction of your stake to keep some powder dry, so you don't automatically have to do a full hand count if you end up pulling up a ballot for Bob, right? So what do you do? Well, it turns out that this problem was studied back in the 1960s, 56, by Kelly. How many of you have heard of Kelly betting? Anybody? This is a big thing in portfolio theory and elsewhere. He basically, in studying information theory and the capacity of communications channels and things like that, came up with a rule that basically amounts to what's the best betting rule if you knew the odds in order to grow your bankroll as quickly as possible. So it's called Kelly betting. It involves knowing what the true odds are, which in this problem would be equivalent to knowing what the real tally was as opposed to what the reported tally was. It would amount to knowing how many votes everybody really got. You don't typically, so what do? Well, you start by, kind of with a guess at what the reported result, what the real result was. So you might use the reported results. If Alice supposedly got 60% of the vote and Bob got 40, you might start by assuming that those are the odds. But then you can learn from your sample and adjust the odds as you see more and more of the population in order to grow your wealth faster. Okay. This is another thing going back to the 1940s that kind of showed the best way to do essentially this thing. I'll just tell a brief anecdote. I realize I'm running out of time. So this is Abraham Wald, in doing work during World War II, came up with this sequential probability ratio test, which was a way of doing things like quality control that instead of saying, I'm going to look at 100 units of something and then stop based on what I see in those 100 units, allowed you to, in some sense, learn from the sample, which might let you do less destructive testing that you would than 100 units or something like that. So it was a way to do things more efficiently. It was seen as such a valuable contribution that he wasn't allowed to publish it until the war was over. It was seen as such valuable intellectual property. All right, so if you're going to do an RLA, what are the key trust assumptions? You need to know that the ballots are trustworthy. You need a trustworthy upper bound on the number of cards cast in each contest. You need a commitment to a way of finding the cards, some identifier of the cards, and I'm not going to go into that in detail. You need to know whether, if the audit says, go get the 17th card from box number 122, that really is what the auditors brought back and the public get to see that. There needs to be a way of knowing that they did the right thing. This is from a paper with Andrew Appel. I'm going to skip over it, but these are some things that audit legislation should have in them to ensure that not only that the audit is rigorous, but also that it really is sufficiently transparent that the public has reason to believe that the audit showed, that the audit didn't stop too soon, that the audit didn't stop without a full hand count if it shouldn't have. Okay. There's a lot of misconceptions about audits. In the interest of time, I'm not going to go over most of these, but I will say that there are some explainer videos on the internet by some esteemed organizations that actually get it wrong. In particular, one thing that's now canonized is that RLAs work by looking at whether the vote share in the sample matches the reported vote share. That's not how RLAs work. They don't involve that at all. And now abuse, right? You know, here one of my sources of discomfort in all of this is I really like the idea of RLAs. I'm proud of it, et cetera. And now they're being used to hide problems instead of to uncover problems and correct problems. And in particular, Georgia Secretary of State Raffensperger has claimed that a really deeply flawed audit of one contest in 2020 based on an untrustworthy, disorganized paper trail, they have no idea how many ballots were actually cast, reaffirmed that the state's new secure paper ballot system accurately counted and reported results, right? And it didn't. It did no such thing. In fact, there were large not only wouldn't it have, even if there hadn't been any discrepancies, but there were large discrepancies even in how many ballots there were, much less how many votes there were for any particular candidate. I've got a paper on this, but I think I'll skip over that. So that's Ron Revest. For those of you who don't know him by name, he is the R in RSA. This was from an early pilot audit in Napa County, California. And the dice there, which were used to generate the seed for the pseudorandom number generator, I've got some of them with me, which we'll use in the simulation. But Ron gave them to me. They're a treasured object. You will notice that they are translucent instead of opaque. That's a security measure. So if somebody loaded them to make them land on one side preferentially, they would have had to do it with something that has the same optical index of refraction as the surrounding medium, right? It's sort of, okay. Okay, and I'll stop there. I'd like to encourage people to come in and play and try their hand at an audit if they're interested during the break. Thanks very much. Do I have time for questions, or just go on? Are there questions? Yeah.
So I'm always curious about metric number of ballots process because selecting a ballot at random from a stack of ballots about as high as the very norm involves a lot of physical work in getting that ballot.
So there's a lot to say about that. So one of them is I actually have a method that I'm trying to patent that allows you to use untrusted technology to print a putative nonce on ballots as you scan them. So you want something like a nonce so you can't trace it back to the voter, but you're not going to trust that it really is a nonce, that whatever's doing the printing might not be trusted. And then use untrusted technology to retrieve a ballot with a particular nonce on it in such a way that the failure modes can only cause you to look at more ballots. They can't cause you to stop the audit prematurely.
There may be some parallels between this and the paper that Ron and I were involved with. Ron and I were involved with a paper on not using untrusted technology on elections that also involved printing on ballots. There may be a parallel.
That'd be interesting.
It got published obscurely in a journal of financial economy. Nothing like experimental.
From the. Thank you.